Hi everyone, it's Miss Berry again. In this video, we're going to go over section 6.3. I'm going to go ahead and share my screen with y'all, and I'm going to remember to mute my camera this time so you don't have to stare at me the whole time. Okay. All right, so we are going over section 6.3, which is called Finding Probabilities Using a Normal Distribution. We're going to be doing the same calculator functions as the last video. The only difference is going to be that instead of working in the standard normal distribution, we're going to be looking at a bunch of different normal distributions with their own mean and their own unique or distinct mean and standard deviation. All right, so let's get started. Okay, so it says, as adults, our body temperatures are normally distributed with a mean of 98.6 degrees Fahrenheit and a standard deviation of 0.73 degrees Fahrenheit. And the question is asking, what percentage of healthy adults have a body temperature which is between 98 degrees Fahrenheit and 99 degrees Fahrenheit? Round your answer to 4 decimal places. All right, so we start by just drawing our little normal curve. Then we're going to put our mean in the middle. Remember, this time we're not in the standard normal distribution. We're just in a normal distribution. So we got to put our little mean in the middle, 98.6. And we're looking between 98 and 99. All right, so 98 is going to be to the left of 98.6, just a little bit. So like right there. And 99 is going to be to the right of 98.6. And we're trying to figure out what is the area under the curve or the probability between these two values. So we're shading in between 98 and 99. That's the area that we're trying to find. All right, so if you remember from the last video, we're going to need a lower bound for the shaded area. We're going to need an upper bound for the shaded area. So that's like, where does the shaded area start and where does it end? And then we're going to need a mean and a standard deviation. Right, so our shaded area goes in between 98 and 99. So our lower bound of our shaded area is 98. That's where the shaded area starts. The upper bound, that's where it ends. So the shaded area ends at 99. All right, so we're going in between 98 and 99. Our mean here in the problem, they told us that the mean was 98.6. And they told us that the standard deviation was 0.73. All right, so now we just need to grab our calculator. We're going to do the same thing. We're going to second VARS. We're going to normal CDF. All right, so let's fill in our information. 98, 99, mean is 98.6. Standard deviation was 0.73. All right, when you're ready, go ahead and hit paste, hit enter. It's going to paste it onto the home screen. Hit enter again to run it. And there's our probability, 0.5026. Excuse me, 0.5026. Okay. So 0.5026. All right, so we would say there's about a 50% chance that, or excuse me, the question was what percentage of healthy adults have body temperatures between 98 and 99? We would say about 50% of adults. All right, let's look at our next question. All right, so same setup, same mean, same standard deviation. This time they want to know what percentage of healthy adults have a body temperature which is above 102 degrees Fahrenheit. All right, so we're expecting this to be smaller, right? Because we're guessing there's not that many healthy people out there who are running around with a body temperature that high. All right, so we put our mean in the middle. 102 would be way out here to the right. That's much higher than normal. And we're looking to go above 102, so we're going to shade to the right. So that's this little area in the tail. All right, so now I need to write down my lower bound of my shaded area, my upper bound of my shaded area, my mean, and my standard deviation. All right, so lower bound of my shaded area. My shaded area starts at 102, so that's the lower bound. And the upper bound, that's where the shaded area ends. That would be way out here at positive infinity. All right, so this shaded area is going to go all the way to positive infinity. So we're just going to do a really big number for our upper bound, big positive number. All right, so our shaded area started at 102. And we're just going to say really big positive number for our upper bound of our shaded area. Our mean is 98.6. Sorry, this is supposed to be mu, but it's kind of sloppy. So mean is 98.6. Standard deviation, same as before, 0.73. All right, so let's grab our calculator. Clear out your screen. Go to second bars, then normal CDF. All right, lower bound was 102. Upper bound was a big positive number. 10,000 will work just fine. Our mean and standard deviation have not changed. So we're just going to go down to paste and hit enter again. And we've got a weird output here. So let me tell you how to interpret this output. So let's just copy down the way it looks. 1.60, 1.6018 65719 E -6. All right, so let me tell you what that means. So back to our screen. Okay. So this was what we got. 1.60186571 E -6. All right, so this tells you one of two things have happened. You've either got a really big number as your answer or a really small number, a number that's really close to 0 as your answer. It all depends on if this number after the E is positive or negative. If this number is negative, it's telling you to move the decimal to the left. If this was a positive 6, it would be telling you to move the decimal to the right 6 places. Since this is a -6, we're going to take this decimal point and we have to move it to the left 6 times. All right, so let's do that. So grab your pencil. All right, 1, 2, 3, 4, 4, 5, 6. I had to move the decimal to the left 6 times. All right, sorry, somehow that got erased. Let me try that again. So starting here, 1, 2, 3, 4, 5, 6. All right, so that's our new location of our decimal. Everything else gets filled in with zeros. All right, so this is 4 decimal places, 0.0000. So 4 zeros, and then another 0, 1, 6, ... It goes on, continues on. All right, but if we were rounding this to 4 decimal places, this is just approximately 0. Right, so 4 decimal places would give me approximately 0. So what percentage of adults are out there with of healthy adults are out there with a temperature above 102 degrees Fahrenheit? We would say approximately 0% of adults, which makes sense. That's not a healthy body temperature. All right. And I think this is our last question with the body temperatures. It says, what percentage of healthy adults have a body temperature which is below 97 or above 100? All right, so put your mean in the middle, 98.6. Mark your two numbers. 97 would be to the left of that mean, and 100 would be to the right. And we're looking to go below 97 or above 100. All right, so below 97 would be to the left of 97, or above 100, which would be to the right of 100. All right, so this is a tails problem. And remember how we deal with the tails problems. We said there's a couple of ways you can approach it, but the quickest way to do it is to say that your shaded area plus your unshaded area have to add to 100% or 1. So instead of finding the shaded area, we're going to go in here and find the unshaded area, this middle part, and then we're going to subtract that from 1. All right, so let's do that. Okay, so we're going to find the unshaded area. All right, so that's the area in between 97 and 100. So lower, upper, mean, standard deviation. My lower bound would be 97, upper bound would be 100, so I'm just going in between these two values. Mean is still 98.6, standard deviation is still 0.73. All right, let's grab our calculator. All right, so clear this out, go to second vars, going in between 97 and 100. Mean and standard deviation are staying the same. All right, go ahead and paste that, run it. All right, so the middle part is 0.9582. 0.9582. All right, so this part in the middle is 0.9582. All right, so that tells me that my shaded area is going to be 1 minus 0.9582. All right, so let's see what that is. 1 minus 0.9582. 0.0418. 0.0418. Okay. Okay. I was just double checking that. That seemed like a weird number. Okay. We are almost done. So you've seen, let's see, we've seen in between. Whoops. We've seen in between. We saw above. So area to the right. We saw area in the tails. So let's see what else we have left. So we've done almost one of each type. It says the weights of cars are normally distributed with a mean of 3,500 pounds and a variance of 52,900 pounds. And the question is asking us to find the probability that a randomly chosen car weighs more than 4,000 pounds. All right, so there's our normal curve. Now, what's weird here is that they're telling you the variance, and our calculator is going to want the standard deviation. So just to remind you of the relationship between those, let's see, if you have the standard deviation and you would like to get the variance, so you take that standard deviation and square it, and that's going to give you the variance. And then the opposite of that would say that if you have the variance and you would like to get the standard deviation, that you just take the square root of whatever the variance is. All right, so that's what we're going to be doing. We have the variance and we would like to get the standard deviation, so we need to take the square root of that variance to figure out what the standard deviation is. So let's go ahead and do that. All right, I'm going to grab our calculator, 52,900. All right, so let's do second, and then the x squared button right here is the radical, and that's 52,900. All right, and there's our standard deviation, 230 pounds, I think it was. Yes, this is the weight of a car, so the standard deviation was 430. Not 430, 230. My bad. All right, let's write that down. Use a different color. All right, so sigma is 230. All right, so the question's asking us to find the probability that a randomly chosen car weighs more than 4,000 pounds. All right, so let's go ahead and put the mean in the middle. Mean is 3,500. Go ahead and mark the number 4,000. That would be to the right of 3,500. All right, whoops. And we're looking for the probability that it's more than that, so we're looking to the right. Okay. So now let's do lower bound, upper bound. So lower, upper, mu, and sigma. All right. Lower bound of our shaded area. Our shaded area starts at 4,000, so that's the lower bound, and it goes on forever, so that's going on to positive infinity. So going on to positive infinity out here. So our lower bound is going to be 4,000, and our upper bound, we're just picking a really big positive number, 10,000. Will still probably work fine. I'll go ahead and throw another 0 on there since we're working with such big numbers in this problem. So I'll do 100,000 just to be safe. All right, and then my mean, they told me was 3,500, and then we figured out that the standard deviation was 230. All right, so let's plug this in. 4,000. Okay. Clear this out. Go to second bars, normal CDF. Lower bound was 4,000. Upper bound, just do a really big positive number. I'm doing 100,000. All right, our mean was 3,500. And our standard deviation was 230. All right, so go ahead and paste that and then hit enter again to run it. And there we go, 0.0149, 0.0149. 0.0149. So the probability that a randomly chosen car weighs more than 4,000 pounds, there's about a 1.5% chance of that, if you were to interpret that probability. All right, and then our last question, what's the probability that a randomly chosen car weighs at most 3,100 pounds? All right, so put your mean in the middle. At most 3,100 means 3,100 or less. So 3,100 would be to the left of the mean, and then we're saying at most 3,100, so that would be 3,100 or less. Now I just need to write down my lower bound of my shaded area, my upper bound, my mean, and my standard deviation. I already know the mean and standard deviation, so I'll fill that in. All right, my lower bound for my shaded area. The shaded area, if we're reading this graph left to right, the shaded area starts out here at negative infinity. All right, so it starts out here at negative infinity, and then it goes all the way to 3,100. That's where the shaded area ends. So that's my upper bound of my shaded area. My lower bound is just a really big negative number. So I'll just do negative 100,000. All right, so just like from the last one, we did our upper bound was 100,000. This time our we're on the opposite side of the normal curve. We're over here on the opposite side of the normal curve. So we're looking from negative infinity to 3,100. And our lower bound, again, is just a really big negative number. All right, so let's plug that in. Clear out your screen, second bars, go to normal CDF. Lower bound, really big negative number. Upper bound, what did we say? 3,100. Mean and standard deviation are the same. So hit paste and then run it. And there we go, 0.0410. 0.0410. 0.0410. Okay. Let me switch back over to my camera. Okay. That was everything for this section. If you have any questions about the normal distribution, please let me know, and I'll see you guys next time.